All right, welcome to The Explainer. Today we're going to dive into a really fascinating family of elements, one that connects our bodies, our tech, and even the night sky. Yep, we're talking about the alkaline earth metals, or as you probably know them, Group 2. So, let's kick things off with a bit of a riddle. What on earth connects your own bones, those brilliant fireworks you see on holidays, and the super lightweight airplanes we fly in? I mean, they seem totally random, right? But believe it or not, they share a pretty profound secret connection.
And the answer is, it all comes down to a single family of elements. So let's meet this family member by member. We're going to find out what they all have in common and what makes each one of them so incredibly unique.
First off, why the name alkaline earth metals? Well, it's actually a clue that comes straight from history. Early chemists figured out that when these elements form oxides, they're alkaline, which just means they're basic. And since they were digging them up from minerals in the earth, the earth's crust, the name just kind of stuck. It perfectly sums up both their history and their basic chemistry.
So what really makes this family, well, a family? Just like any family, they've got these shared traits, a kind of chemical DNA that links every single one of them together. Let's dig into what that is. Okay, this right here, this is basically their chemical DNA. Just look at that pattern in the electronic configuration column. See it? Every single one of them ends in S squared. That's the secret sauce. It means they all have exactly 2 electrons in their outermost shell, and that is the key to everything. Those 2 electrons are just begging to be given away in a chemical reaction, and that really defines their entire group personality. And to really get a feel for them, it helps to compare them to their next-door neighbors, the Group 1 alkali metals. So on the left, that's our group, Group 2. They're harder, stronger, and they've got higher melting points. They're definitely reactive, but not quite as, let's say, dramatic as Group 1. And the biggest difference, they have those 2 outer electrons to lose, which is exactly why they form ions with a +2 charge. Now, as we travel down the group on the periodic table, from beryllium all the way to radium, a super clear pattern pops up. First thing, they just get bigger. It's like adding rings to a tree trunk. Each step down adds a whole new shell of electrons, so the atoms themselves just naturally swell in size.
And that leads us right into the second big family trend, reactivity. It also gets bigger and bigger as you go down the group. I mean, think about it, right? As the atoms get larger, those 2 little outer electrons are way farther from the nucleus, which is trying to hold on to them. So they're much easier to just pluck away in a reaction. It's why an element like barium, way down at the bottom, is so much more reactive than beryllium up at the top.
Okay, so we've seen the family resemblance. Now it's time to meet the individuals. Each member has its own totally distinct personality and, its own job in the world. Everything from making our technology stronger to literally building our bodies. First up, we've got beryllium, the lightweight powerhouse of the family. This stuff is incredibly light, but it's also surprisingly strong and really stiff. But it's also kind of the difficult one in the family. Its compounds are toxic, so it always has to be handled with extreme care. So where do you actually find beryllium at work? Well, its resume is packed with some seriously high-tech roles. You'll find it in aerospace parts, making things both light and strong. It's in the windows of X-ray tubes because it's basically transparent to X-rays. It's even found inside nuclear reactors. This is a true specialist material. Next in line is magnesium, the brilliant show-off of the family. If you've ever seen an old camera flashbulb go off, or maybe a military flare lighting up the night sky, then you've seen magnesium doing its thing. When this stuff burns, it creates this just blindingly brilliant white light. But magnesium is so much more than just a pretty flash. It's a total workhorse. We're talking lightweight alloys for cars and planes. It's even used to literally sacrifice itself to protect steel from rusting. But here's the part that'll blow your mind. It sits at the absolute heart of the chlorophyll molecule. Without magnesium, there's no photosynthesis. No photosynthesis? Well, no plant life as we know it. It's that important. And now we come to calcium, the master builder. This element is all about structure. Seriously, it's the foundation for so much of our world, from things you can only see with a microscope to massive, monumental structures. Just take a look at calcium's career highlights. It's the literal foundation of our world. It's the mineral that gives all the strength to our bones and our teeth, but it's also the basis of cement and concrete, the stuff we use to build our cities. From the farm, where it's used to treat acidic soils, to the factory, where it helps pull other metals from their ore,
Calcium is a true workhorse. Let's meet strontium, the artist of the family. This is a soft, pretty reactive metal that has one very, very famous talent. It produces a spectacular, vivid crimson red color when it burns. So the next time you see a brilliant red firework lighting up the sky, you'll know that you are looking at strontium at work. It also used to have a job making the glass for old-school TV screens, and some of its radioactive versions are actually used for medical scans. Moving further down the family tree, we meet barium. Now, this one is the heavyweight of the group. It's highly reactive and incredibly dense, and it's that density that lands it a really surprising and vital role in medicine. You know, if a doctor has ever needed to get a good look at your digestive system on an X-ray, you might have had to drink this thick, chalky stuff. Well, that's the famous barium meal. The barium sulfate compound is super dense, so it's completely opaque to X-rays. It basically coats your insides and lets them light up, clear as day, on the scan. Beyond its starring role in X-rays, barium also gets in on the fireworks action, creating those bright green colors. And going back to its density, in the oil industry, it's a key ingredient in the heavy muds they use for drilling deep wells. And finally, we get to the last member of the family, radium. It's sort of the mysterious, unstable relative with a dark and dangerous secret, a secret that sets it completely apart from all the others. And that secret is simple. Radium is intensely radioactive. It was famously used to make glow-in-the-dark paint for watch dials, long before we fully understood just how dangerous that was. Its story is a really powerful lesson about both the incredible promise and the terrifying peril of the elements. So, when you think about it, from the aerospace alloys made with beryllium to the bones built by calcium and the medical imaging we get from barium, this one single column of the periodic table has a just profound and incredibly diverse impact on our lives. And that kind of leaves us with one last thing to think about. If this entire family of elements just, poof, vanished overnight, what would you miss the most? Would it be the lightweight cars, the spectacular fireworks, or would it be something way more fundamental, like, the very bones holding you up right now? It's pretty wild how much we depend on this single column of the periodic table. Thanks for joining me.